Hello, our most developed student. My name is Confident and welcome to our 24-minute lesson. This is the ultimate guide in maths, science, career guidance, as well as a sneak peek in my personal experiences. This is a channel that is designed with you in mind. Let us dive into today's lesson. In this lesson, we are going to continue on the sequence and series, and we are looking at the geometric sequence. And the geometric sequence follows the arithmetic that we did in the previous lesson, and if you didn't get hold of it, I'll encourage you to do so. It is an important lesson for the foundation that you need as you continue on this chapter. Now, geometric sequence also, there is the general term that you need to know for the geometric sequence, which says Tn is equal to a r n minus 1. Now remember the arithmetic sequence, we said what? Tn was equal to a plus what? Plus n minus 1 and d. And we did explain d was the common difference, a was the first term, and this is the position of the term. But now with the arithmetic sequence is a bit different on this part, because with the geometric sequence it's a bit different, because geometric, it's more of not linear. This was linear, but this is exponential. It's more like you're looking at an exponential graph. These are exponential, sometimes called exponential sequences. Now, what does A stand for? Similarly, A stands for the first term. Nothing has changed. It's still the same like the previous one, but R, which now in a way kind of is similar to D, but this one represents the common ratio. Just know that difference. It's common ratio. And then N is still the same. It represents the position of the term. If N is 5, it means that term is in the 5th position, or T is equal to 5. Position of term. Alright, so with that we can look at an example. It says consider the following sequence, and they gave us this: -5, 10, -20, 40. Show that the above sequence is geometric. Now, this is what I wanted to bring in the previous chapter to say. In an exam, they can just give you a sequence and not indicate whether it is arithmetic or it is geometric. Don't just apply the formulas. First, you need to test. It is very, very important, because you might think it's arithmetic only to discover that it does not meet the conditions of an arithmetic. So how do you test that something is geometric? It comes from the what? From the formula. Remember, let me write the sequence down. We have -5, we have 10, we have -20, we have 40. Now there is something special, unlike the common difference in the geometric sequence. What you need to know, so if this was T1, T2, T3 and T4, what you need to know is the common ratio, this R that you see here on the formula. Okay, let me write this formula. Tn is equal to a r n minus 1. Now this R that you're seeing, you find it by saying T2 over T1. So let's start with the first one. T2 over T1. What do you have? You have got 10 over -5. And then what is that? If you divide there, you get -2. Let's try another one again. We can try T3 over T2. It's just the T3 minus the previous one. If it's T3, it's the T2. If you say T4, it's minus the previous, it's over the previous one. So is the T3 is gonna be T3 over, now you say T2, you see, is the one in front of divided by the previous one, which is -20 over 10. And guess what? You are also getting a what? A -2. Hence it's called the common ratio. You can try again the other one, T4 over T3. What is T4 over T3? It's 40 over -20. Guess what? You are still also going to get a -2. You cannot say, I'll make it red. You can't say R is T3 maybe over T1. No, it must be T3 over T2. If it's T2, it's divided by T1. You must follow the formula for R. So then the question was simple: show that the above sequence is geometric, and then you can say R. Here you can say R is equal to minus 2. Sorry, this is not how you show it. You're going to say here T2 over T1 is equal to T3 over T2, and then you say, which is equal to minus 2. Say therefore it has a common ratio. You can say that it has a common ratio. Once it has a common ratio, it means it's geometric. Or you can here conclude by just saying this, say therefore it is geometric. Just by saying that, you're already telling us this sequence is what? Is a geometric sequence. It's saying T2 over T1 is equal to T3 over T2. And then the next one says determine the value of the 20th term. The value of the 20th term of the above sequence. Now what to do there when you want to find the 20th term? Remember, you know your what? You know your R. What is the common ratio? R is negative 2. And then what is our first term? A there is T1, which is equal to what? A is equal to T1, which is equal to negative 5. Are you with me? And then you can from here find the general term Tn, which is equal to A Rn minus 1. Tn is equal to A, which is negative 5, times, better to put it times now, times R. What is the R? Is negative 2. And then look at this, you need to be very careful now. Put a bracket also on negative 2. And then N minus 1. So it is equal to negative 5. If you don't put a bracket times, you can even leave the times, since the bracket will come in negative 2 N minus 1. That's it. That's the end of this, the general term. And then the question was determine the value of the 20th term. You see, 20th, where N is what? Is 20. So you come and say T20 is equal to minus 5 bracket minus 2, and then what? 20 minus 1. Rely what? Rely mainly on the calculator, because it's the one that can easily calculate this. Negative 5 bracket, don't forget the bracket, negative 2 to the exponent 20 minus 1, which is 19 there. Then you write that answer, which is what? 2,621,440. 2,621,440. I hope it's the one that was that. All right. But if I made an error, you can correct that part. So what is this, guys? This is geometric. Now let's try another one, and then see if ever it makes sense. All right. The other one here, it says, this question says, consider the following sequence. Then they give us this sequence. What is this sequence? This sequence is 0,625, and then you have got 1,25, and then you have got 2,5, and then you have got 5. So what is this? Your T1, your T2, your T3, and your T4. You see, now determine the value of the 10th term. Now it's easier because I'm dealing with the geometric, but in an exam you might not know what you're dealing with. So what I will encourage you quickly take the calculator just to test what you're dealing with. You start with the arithmetic. Remember, it's T2 minus T1, which is 1,25 minus 0,625. Check the answer. It's what? It's 0,625. Try the other one. 2,5 minus 1,25. Check whether you're getting that answer. You see, now I'm getting 1,25, not 0,625. So it means it's not arithmetic. That's when now you can relax and say, okay, it might be more of a what? More of a geometric, because you first ruled out the arithmetic. It must be one of those. So now, since it says determine the value of the 10th term, we need to find the general term. Now let's find R first. What is R? It's T2 over T1, which is equal to T3 over T2. Still good just to have those two types there. What is that? It's 1,25 over 0,625, which will be equal to 2,5 over 1,25. You can just test that to see whether you're just getting the same answer. There is no harm, because you're just trying to be 100% sure that it is indeed a what? A geometric. In an exam, they won't tell you what it is. You're getting a 2 there. Let's try the other one. It's 2,5 over 1,25. You see, it's giving me a 2. So this is the common ratio. Then after that, you can then write Tn is equal to A R n minus 1, which is equal to, what is our A? A is T1, the first one. This is your A, which is 0,625. You can put a times or put a bracket. I think the bracket is better. R is 2 bracket n minus 1. Then that becomes the general formula for the nth term of that sequence. Now they say determine the value of the 10th term. Then you need to say, all right, let me find now T10. See that now. So you need to pass through that stage, which is 0,625. Someone will argue and say, but not necessarily understand, but just try to pass through the stage is always the better way of doing it, because you can follow your steps. You can track to say, if you make an error, you will know, okay, let me try to track my steps. Where might I have lost it? 0,625 bracket 2 to the power 10 minus 1. Then you get that answer, which is 320. So that's the first one. Then determine which term will equal 80. Now I want to pay attention of B. Please, NB, NB, NB. Let me put this as NB. Pay attention on question B. It says what? Which term will equal 80? So it means now I already want the position of that term, meaning they have given me that Tn is equal to 80. Now they want me to find n. So now this is where your exponents comes in. Now remember, you know what is Tn. You know that Tn is also what? Is also 0,625 bracket 2 and then n minus 1. So you've got two Tn's now. They told you that the Tn must be 80, and then now you just equate, whereby you are going to say, because they are saying which term, so you are going to say here 0,625 2 to the power n minus 1 is equal to 80. Are you with me? Now you need to know how to solve for n here. Please don't panic. Look at this. It's exponents. First things first, there is a times here. Divide by 0,625. Remember that. Over 0,625. I want you to remember the stage that I'm doing is to always be the same. If there was no number, it's still fine. You'll do the next step. So you'll have 2. Now you can remove that bracket. Is equal to, you can still put it, is fine. Now take a calculator and find out what is 80 divided by that. 0,625. Then 128. They will give you numbers that make sense. 128. So what you do, you come back to the laws of exponents. Remember the law which says if a to the power x or a to the power m is equal to a to the power, is equal to b, actually is equal to a to the power n. Let me use that one. Is equal to a to the power of n, whereby the bases are the same, there is an equal sign. You can say therefore equate those exponents. These exponents are also equal. M is equal to n, meaning try to express 128 in terms of exponents. And I think if you do that, you can express 128 in terms of exponents. Am I right? Let's say 2 to the power 6 is what? 64. 2 to the power of 7 128. You see that now? So this then becomes 2 to the power of n minus 1 is equal to 2 to the power of 7. They always give you something that makes sense. They don't just throw things at random. Now the bases are the same. You can do the same. Equate these exponents, whereby n minus 1 is equal to 7. Then take -1. It's negative. When it jumps, it becomes positive. So n is equal to 7 plus 1. And what is our n? N is equal to 8. So here we are saying if n is 8, that the Tn will be 80. You can test it here. You can test it here by putting 8. You put 8 and see what you're going to get. Remember, actually we put 8 here is better here, and you put 8 here. It must give you 80. You can just quickly test that with the calculator to say, if I say 0,625 bracket 2 to the power of 8 minus 1, it must give me 80. You see that? So that's how you solve these questions, guys. It's the geometric sequence. Now, as we continue, we're now going to look at the summations, the summation, the sigma notation. That's what we're going to do, whereby when I'm talking about the sigma notation, I'm talking about this notation and the sum of terms, and we're going to look also at the sum of terms for both arithmetic sequence and geometric sequence. Okay, so this is very important for you to follow up the next videos. So if you're not subscribed, I will encourage you to do that so that you can be notified when these videos are being uploaded. Thank you.